In video 3, I'm going to show you how to convert slide 4 from the YouTube presentation PowerPoint template into slide 4 of your final presentation. To do this, I'm going to open up the spreadsheet that we put together as a class. It is located on my website. You scroll down until you get to rent.com. Spreadsheet for final presentation, spring 2015. Click on that, and then you can open up the spreadsheet here. This looks familiar, right? We have our Y variable in column B, the thing that we want to predict. We want to predict why rent might go up or down and what affects it either negatively or positively. And then we had all 37 variables, independent variables, that we had collected information on. And we have 37 variables, and each of those variables had an observation. And we had 123 observations total. So now Excel can't do a regression on a group of x's that exceed 16. So what I did is I just copied this data. I copied the Y, monthly rent, and the x's. I copied all this and pasted it into a program called Stata, which is a regression package, regression software. I copied this and I pasted it into Stata and I ran the regression. Then I copied those results from Stata back to Excel. And the regression output I got is right here on the tab down here that says reg results 37x's. The one I did in class is right here. This is one I did for class, and these are the regression results for 16x's, the maximum number of x's that Excel will allow for regression. But for the final presentation, you need to use the full model, and this right here is the full model. There are 3 tables in the regression output. There's the regression summary statistics, and that includes the adjusted R-square. I'm going to note that. I'm going to make that bold. I'll make it bold and red because we're going to come back to that later on. I'm also going to make the I'm also going to point out the fact that Excel calls the p-value for f. Excel calls it significance f. I like to call it the p-value because it's a p-value. And then Excel will have residual here instead of error, which is confusing because this right here is the SSR, sum of squares due to regression. And this is called the SSE, sum of squares due to error. So if that says residual instead of error, some people might mistake this for SSR, which is right here. So I like to make those changes to the Excel output. Now I'm gonna make this here bold and red because we're gonna come back to it later on. Now down here is our table of estimated coefficients. Standard error shows up in the overall regression statistics table. The word standard error also shows up in the coefficients table. This standard error is called the standard error of the regression. Standard error of the regression. Okay. Down here we have the standard error, and there's a standard error for the intercept. There's a standard error for each of the estimated coefficients. So we have 37 standard coefficient standard errors, We have 37 of them. We have a standard error for the intercept, and we have a standard error of the regression. The t-stat, like it was in chapter 10, difference of means, the t-stat is the point estimate minus 0 divided by the standard error. So if I divide this by that, I get 2.4. If I divide 110.6 by 38.4, I get 2.9. Yada, yada, yada. So this right here is just the ratio. These right here are just the ratios of the coefficients divided by the standard error. Now the coefficients down here that are in blue bold font, these rows that are in blue bold font correspond to significant predictors of rent. How do I know that? Well, if you look over at the p-value, the p-values are all less than 0.1. These p-values are less than 0.1, 0.1 being the significance. Now I picked 10% significance because it's Friday, and I like 10% significance on Friday. On Thursdays, I prefer 5% significance. So typically 10%, 5%, and 1% are common levels of significance. But these p-values are less than 10%. These p-values are less than 10%. That p-value is less than 10%. And then we have 1, 2, 3, 4, 5, 6. We have 6 other scenarios where the p-values are less than 10%. Where the p-values are greater than 10%, the font has not been changed in terms of color, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have a bunch of other p-values that are not less than 10%. And so these variables here, these variables are said to be insignificant predictors of rent. There's another way you can determine the significance. You can look at the, you can compare the test statistic to the critical values of the test. Over here I have lower critical values and upper critical values for each variable, each independent variable of the regression. There's upper and lower critical values in each row of the coefficient table. The degrees of freedom for this test is equal to 85. Where did I get the 85 from? Each t-test for each coefficient has the degrees of freedom equal to the sum of squares error degrees of freedom. In this case, 85. So we use 85 degrees of freedom, and if we picked, we have a significance level of 10%, 0.1, these hypothesis tests are two-tailed, so we have to divide the alpha by 2. So if we're in column 0.05 and row 85 of the t-table, we get 1.663. And because this is a two-tailed test, we have a negative 1.663 critical value and a positive 1.663 critical value. And then all you do is you ask the question, is the t-stat in between these two values? 2.4 is not in between negative 1.663 and 1.663. So you conclude that that is not 0. A better way to conclude is to say that that 78 is significantly different than 0. Another way to say it is that point estimate of that coefficient, that estimated coefficient is significantly different than 0. And notice that the t-stats that are in blue bold font are not in these intervals. So down here we have t-stats that are inside these critical values, which means these estimated coefficients are insignificant. These t-stats are not in these intervals, which means these estimated coefficients are not insignificant. In fact, they are significant. So that's how you do the individual t-test. Now, each one of you guys have been assigned a variable which you guys summarized with monthly rent in slide 2 of the PowerPoint. You also did some more analysis and an additional hypothesis test for that variable that you were assigned for slide 3. In slide 4, you're going to take that same variable that you were assigned to analyze with monthly rent. You're going to do the coefficient significant test for that same variable. So, for example, remember, in slide 2, I summarized washer and dryer and unit with monthly rent. In slide 3, I was asked to test whether the rent was greater when a washer and dryer was included. In slide 4, I'm going to test whether that coefficient is significant formally. I'm going to have to state the null hypothesis. I'm going to have to state the results of the test, yada, yada, yada. So I'm going to formally present this test in slide 4 of the Final Presentation PowerPoint. You guys will, each student will do the same with a variable they were assigned to analyze with monthly rent. So, for example, Andrew will take this information here and put it in his slide 4. Cody, in my Tuesday, Thursday section, will take this information here and put it in his slide 4. Thomas will take this information here in this row and put it in his slide 4, etc., etc. So I think you kind of get the idea now. So I'm going to pretend that I'm a student in the class, and I'm going to take the information from my variable, washer and dryer and unit. I'm going to take this information and put it in my PowerPoint. So I'll go ahead and copy it. I'm also going to note that bedroom is variable 1, bath is number 2, square feet is number 3, washer and dryer is the 12th. My variable is the 12th x. And there are 37, right? There's 37 total x variables, right? 37 total x variables. And mine is the 12th. So let me open up the PowerPoint. Remember, if I click on this link here, I get the PowerPoint template for the final YouTube presentation. The unaltered slide 4 from the template is right here. This is the model that we are estimating, that we have estimated together in Excel. Well, technically, we estimated this model in Stata because we had 37 independent variables, and then we had to estimate 37. We used Stata to estimate 37 parameters. Now, my variable was the 12th, right? My variable was the washer and dryer in the rental unit. So I'm going to change the I to 12. Okay. And then down here, I'm going to go ahead and delete the first part there and change this to the coefficient significant test for washer and dryer in unit. In the statement of the null and alternative hypotheses, I have to change the I to 12 in both statements because my variable was the 12th. My variable is the 12th in the order of the independent variables. X12 is washer and dryer. It's the 12th from monthly rent. I'll go back and show you. So the X1 is bedroom, X2 is bathroom, X3 is square feet, yada yada yada. Wash and dryer is townhome is the 11th. Wash and dryer unit is the 12th. So I'm testing whether beta 12 equals 0 because the variable I was given was wash and dryer unit, and that is X12. So when you're putting together the fourth slide, make sure you put 37 here, 37 here, and then as long as you don't have the first variable or the second variable, we'll go back to Excel to see that. Andrew, Dex, Cody, and Chandler, you guys have bedroom and bath. This is X1 and this is X2. So I just forgot. For what is it, Chandler and Andrew, you guys are testing whether this is 0 or not. For Cody and Dex, you guys are testing whether this is 0 or not. And then because there's a yada yada yada, everybody else will just change the 12 here. We'll change the 12 to whatever variable yours is. Mine was the 12th, right? So for Andy and Chandler, you would state your null and alternative hypothesis as beta 1 equals 0, beta 1 not equal to 0. For Cody and Dex, you guys would have to put 2's here. Okay. Now, since my variable is the 12th, I have to have a subscript 12. So beta 12 is the coefficient of the 12th X, which is washer and dryer unit. Now, the information right here has to be altered using the information from your row. My row is the wash and dryer unit. So I'm going to open up Excel, and I'm going to get the estimated coefficient. Now, I'm going to go ahead and add some decimal places here. So maybe 2. That's probably good right there, yeah. I'm going to grab the estimated wash and dryer coefficient. This is B12. B12 is the estimate of beta 12. So I'm going to replace that with my value from the row that I'm supposed to analyze. And we'll use 2 decimal places. The next thing I need to do is get the standard error of that estimate. The standard error of that estimate is 28.219. And I'm going to use 2 decimals. Next, I'm going to get the t statistic. Now, you can literally, if you wanted to, take this and divide by that, and you'll get the t test statistic. But Excel reports them, so why do it, right? The test statistic is 4.21. You can leave it as 5% if you want, but why not change it to 10? Why did I say change it to 10? Because if you look over here, I already got the critical values, right? 1.663 for a significance level of 10%. So I'm going to change the significance level to 10%. I'm going to copy that value, 1.663. And I changed that to 10%. Now I got to change the degrees of freedom. Remember, the degrees of freedom are the sum of squares error degrees of freedom, 85. This is what your fourth slide should look like. I have 12 here as a subscript of beta 12 and x12 because the 12th variable is washer and dryer in unit. I want to know whether beta 12 equals 0 or not. So the null hypothesis has been changed to beta 12 equals 0. The alternative is beta 12 not equal to 0. We cannot know the value of beta 12, so we've estimated it using regression analysis. This is B12. B12. It is an estimate of beta 12. This is B12's estimated standard error. The ratio of those two things is called the test statistic. We use 10% significance, 85 degrees of freedom. That is the degrees of freedom of sum of squares. And if I divide this by 2, I'm in column 0.05. Row 85, the t-table gives me 163. It's a two-tailed test, so I have a negative 1.663 and a positive 1.663. I'm testing whether or not the 12th estimated coefficient is 0 or not. If you're testing, say, whether or not Poole's coefficient is 0 or not, then Poole is the 14th variable in the ordered list of x's, and you want to know whether or not that is 0 or not. The people that are doing that are Emma and Dylan. So Emma and Dylan, you would change this subscript to 14, that subscript to 14, that subscript to 14, and that subscript to 14. And then, of course, this would be Poole, right? So you change that to Poole. And then, of course, Emma and Dylan, you'd have to, change these values here from those values to the ones that are in your rows. So you just copy these values here into there, and then your slide 4 would be done. If you were the student that was assigned to test whether or not the washer and dryer was a significant predictor of rent, this is what your slide should look like. Summary, washer and dryer is x12, so we have x12 here. We want to know if beta 12 equals 0 or not, which is where if beta 12 equals 0, we have the null hypothesis. If beta 12 does not equal 12, we have the alternative hypothesis. We have the estimated coefficient. This is B12. B12 is an estimate of beta 12. Beta 12 cannot be known, so we've collected data and estimated it. The estimated beta 12 is 118.82. It has a standard error of 28.22. The test statistic is this minus the hypothesized value divided by the standard error. The test statistic is given by Excel. And then if we use a 10% level of significance and the sum of square errors degrees of freedom is 85, the critical values are negative 1.663 to 1.663. And since this test statistic is not in between these critical values, we say this test statistic is not insignificant. In other words, it is significantly different than 0. So what does that mean? It means the estimated coefficient is significantly different than 0. And since washer and dryer unit has one of two values, 0 if there's no washer and dryer in the unit, 1 if there is a washer and dryer in the unit. When washer and dryer goes from 0 to 1 in value, you're going from not having a washer and dryer in the unit to having a washer and dryer in the unit. And when you go from 0 to 1 here, no washer and dryer to a washer and dryer, the expected value of the rent rises by $118.82 per month. So, what does that mean? If you're a landlord and you supply your units with washer and dryers, you can charge an extra $118.82 per month to your tenants.